Okay, so extreme value theorem means that if your function's continuous, somewhere on the interval, you're going to have a relative maximum and a relative minimum. And so what we mean by that is within a local region, you're going to have a highest point, and within a local region, you'll have a lower point as well. And we call them local. The absolute or the global would be the highest, the highest point in the entire graph, and same thing with the minimum, the lowest point in the entire graph. But local just means within that region. And by the way, they're all called relative or local. You know, we're using different terms for that. The main thing, though, that this assignment is critical points. So these are going to occur at what we call critical points. So what is a critical point? A critical point is when f prime of x equals 0, or maybe it's not differentiable there. And I put x0 to represent that exact spot. And this can happen multiple times, but when the derivative is 0, or it does not exist, then that's called a critical point. And that's where we could possibly have these minimums or maximums, which makes sense because if the slope was 0, you would have a horizontal tangent. It's not necessarily a maximum or minimum because it could continue to increase and have that horizontal tangent that where the derivative is 0. But more than likely, or if there's going to be a maximum or minimum, it's going to happen at those spots. And why do we say not differentiable? Well, remember those corners and cusps that we talked about before? It's not differentiable at that spot, but we do have relative extrema. We have a maximum or minimum. That's what I mean by extrema. So critical point is where our derivative is 0 or undefined. So we're going to choose all the places where this function has a critical point. So let's go ahead and start with the derivative. So h of x is x squared plus 4 to the 1/2 power. So h prime of x is 1/2 x squared plus 4 to the negative 1/2 power times 2x. Now the 2 on the top and bottom will cancel. This will become x over the square root of x squared plus 4. Okay, now basically we're looking, when is the top 0, when is the bottom 0? If the top is 0, you have that the derivative of the function is 0, so that's a critical point. So that would happen, we're going to set the top equal to 0. And that's it, x is 0 is one of the others. Let's go ahead and set the bottom equal to 0 as well and see if the denominator is 0. That's where it would be not differentiable. So if we subtract 4, x squared equals negative 4, square root both sides, and there's no value of x, no real value of x that's going to make that true. So that doesn't work. I'll put an x there. So our only spot's going to be 0. And that's the main idea. So this one's pretty simple. Find the derivative, set it equal to 0. It's going to be a quadratic, so you're probably going to get 2 answers out of that one. And I'll give a detailed solution of that later. Let's go ahead and I'll give a detailed solution of this one. Let's do the trigonometry one. So let's start with the derivative. So the derivative, and then we're going to set it equal to 0. If there is a denominator, we set that equal to 0 to see if it's undefined or that the derivative doesn't exist there. But this derivative is negative sine of x plus 2. So let's set that equal to 0. And solve. Now think about this. Can sine of x equal 2? And you might have to go back to our right triangle trig that we learned. So sine is opposite over hypotenuse. Isn't the hypotenuse the largest side? So because hypotenuse is the largest side, sine can never be greater than 1. So this is going to have no solution. So this has no critical points. And that's the idea. You just want to find out where's the derivative 0 or where is it undefined. You can have multiple critical points, and that's the idea of the critical points.